Welcome back to Physics 141 Online. Today I'd like to work through at least the setup part of one of your homework problems that's available through Mastering Physics. This is problem 465, and I've got it open in the window here. I'll talk through what the problem is actually saying, and then I'll go to my notepad so that I can show you how to set the solution up. The problem says two masses are joined by a massless string. And then it specifies a 31 Newton force applied vertically to the upper mass gives the system a constant upward acceleration of a certain value. And of course, your problem will have different numerical values here. Part A says if the string tension is 19 newtons, or whatever value you get, what is the smaller of the two masses? And Part B says if the string tension is the same value, what is the bigger of the two masses? So clearly, the problem wants us to use a given force that causes a particular acceleration and a string tension to find out the values of the two masses. It's just that we enter the smaller one in part A and the larger one in part B. So that's the problem, and next I'll show you how to set it up using the problem-solving steps for applying Newton's laws to motion problems, just like this. Okay, now you can see that I've translated the problem into a form that just uses symbols. And of course, this is what I recommend you do on all of your homework problems as well. Purely symbolic solutions until you're ready to plug in the numbers. And so this solution here that I outlined should apply to everybody. Each of you will just have different numbers for the given quantities, which in this problem are the force F, the acceleration A, which we're told is upward, that's important as well, and then also the string tension of T. So you'll have numbers for those three things that can be plugged in order to find the final numerical values. But first, let's draw a sketch. Since the problem did not give us a sketch, we've got two masses, right? And you can call them anything you want, but I will call the upper one M1, and then it's attached to a second mass, M2, by a string that has a tension T. And then I will just put on my sketch that the system is accelerating upward with an acceleration A. Now we'll pick a coordinate system, as we always should do in problems like this. I can do it here very easily because the only direction either for the acceleration or for the forces is in the vertical direction. Sometimes it's best to wait till we draw the free body diagrams before we choose a coordinate system, but here it's fairly simple. So the first step, of course, is to write down the free body diagrams for the masses, and we do this separately. We figure out separately what the free body diagram should be for M1 and for M2. We've recognized already in the identify step that this is a Newton's second law problem, and now we're going to develop a solution which amounts to drawing the free body diagrams and writing down Newton's second law for each of the objects. So the free body diagrams, here we are for M1. All right? And M1, you can see that there is a force F upward. There is then, of course, the tension T in the string downward, and it's easy at this point to forget that there's also the weight. That the weight, which is W1, we know that that's equal to M1 times G, right? So I'll put that down. W1 equals M1G. But that force is acting as well. That's M1. Then we have M2, and the upward force on M2 is provided by the string. The downward force is, again, the weight, W2, which is M2 times G. And it's really important in problems of this type to keep track of the subscripts. If you just put mg for these two weights, you will think that those masses are the same, and you'll get the wrong answer. So now we've put in the free body diagrams, and we move on to write down Newton's second law for the two masses. So for M1, The only direction of the forces is in the y direction, and so I'll add up all of the y components of the forces, and according to Newton's law, second law, that should be m1 times a1. And of course, in this problem, m1 and m2 are tied together with this string, so that as long as the string does not stretch, they should have the same acceleration. So this a1 is nothing more than a, and so I'll just leave it as a in this problem. But the forces in the y direction, now I go to the free body diagram, and one of those is F. That's a positive force because it's upward. The y direction is positive, upward. And then we've got minus T and minus m1g, because those two forces are in the negative direction, equals m1a. And that's my equation 1. That's from mass m1. For mass m2, we have a similar equation, only on the right-hand side we've got m2 times the acceleration a. And from the second free body diagram, this becomes T minus m2g equals m2a. And that's equation 2. So what am I trying to do? I want to find, I probably should have written this down at the outset, but I already mentioned it in the description of the problem. We want to find m1 and m2. None of those are given in the problem. Only the force F, the tension T, and the acceleration A are given. So we want to find those. And let's look at the equations. We'll look at equation 1. What are the unknowns in it? The only unknown in equation 1 is m1, because F and T and A are all given. G, we know the value of G, so m1 is the only unknown. So from equation 1, let's just get the two m1 terms together on the same side of the equation. And I can get that by adding m1g to both sides, which gives F minus T equals m1g plus m1a. And of course, the whole point of doing this is that I want to factor out the m1, make it g plus a. So F minus T is equal to m1 times g plus a. And as I said before, everything in here except for the m1 is given. So I will leave the last step to you to solve for m1, right? And then we're done. We figured out what n1 is. From equation 2, we write that down again. We see that in equation 2, the same kind of situation prevails. m2 is the only unknown. So I can add m2g to both sides and get T equals m2g plus m2a, or T equals m2 times g plus a. And from this equation, I can solve for m2. It's just a matter of simple algebra to do that. And so that really should solve the problem. If we go back to mastering physics, remember in part A of the problem, it asked for one of the masses. In part B, it asked for the other one. And I can't remember which was which, but one of them said enter the smaller of the two masses and then enter the larger of the two masses. So once you get numerical values for m1 and m2, you'll know which one to enter in which part. So the problem there is basically finished, and it's really not that difficult as long as you're careful about drawing the free body diagrams and then write down Newton's second law for each object separately. Now, this problem is not the same as all the problems that you have. Sometimes you'll need to combine equations 1 and 2 to get rid of one of the unknowns in order to then solve for the other one. But in this particular problem, equations 1 and 2 could be used individually to solve for the desired masses. So hopefully this will help you on this problem and similar problems that are assigned on your homework. I'll see you in class.